This is a trigonometric question. This is from NCERT book. So usually what happens is most of you will understand, but the main thing is try to understand why those steps are written, why you are doing it so that you don't have to memorize. So the question says angle P and angle Q are acute angles such that, so there are two triangles. Angle B and angle Q are acute angles. So that means if I am going to take A here, I can't put B. B is acute angle, so I'm going to put B and C here. Similarly, I'm going to put P. Q is acute angle. If I put P here, then you'll have to put Q there. So just make sure that you have similar notations, and then comparison will be easy. Acute angle such that sin B equals to sin Q. So sin B, so if I take, if I'm talking about trigonometry, so this will be my hypotenuse. Angle B and angle Q, if I talk about, this will be my opposite or perpendicular. This is my opposite or perpendicular. However, you have learnt it. This will be my base or adjacent side. This will be my base and adjacent side. So based on that, we'll try to write the ratios. So sin B is equals to, which is opposite by hypotenuse, opposite is AC by AB. Similarly, sin Q is actually going to be opposite, which is PR by PQ. So we have written the ratios, and the condition what they have given is sin B equals to sin Q. So that means AC divided by AB equals to PR divided by PQ. Or if I rewrite this, because this belongs to one triangle and this belongs to another triangle, we have just written sin ratios and then we have just equated them based on the condition given. So if I actually do the cross multiplication here, AC divided by PR equals to AB divided by PQ. The reason why we wrote this is that I can compare both the triangles. If I am comparing both the triangles, what I have done is, here I have written the ratios are equal. We know from triangles chapter, and mainly using triangle similarity, I have written that ratios are same, and that ratio actually has to follow certain criteria. So if I look at this, I have side here, this is side. I'm comparing these two sides and ratios are written equal, but my criteria says either I should use SSS, SAS, RHS or AA, any one of them. So here I cannot come up with any angle. Angle is not given, but we need to prove angle B equals to angle Q. So that means I need to show some similarity, then I can come up with angle B equals to angle Q once that similarity is proved. I cannot just say two triangles are similar just because two sides are proportionate. So based on that, the third one what we need in this scenario is AC, PR, AB, BC, BC by QR. That's what we need. So for that reason, what we are going to do here is, we know that these are right angle triangle. That's how we have taken for trigonometry. So if I use Pythagoras theorem, the reason behind that is, how do I get BC and QR? BC and QR I can only get by using Pythagoras theorem. So let's say if I write for the first triangle, that will be AB square equals to AC square plus BC square. Pythagoras theorem, square of hypotenuse is equals to sum of the squares of the other two sides. So similarly, but I need BC and QR. So I'll be needing BC on one side, at least left hand side. So that will be BC square equals to AB square minus AC square. If I transpose this, that's what will happen. But BC will be equals to square root of AB square minus AC square. Let's just call this 1 here, let's just call this 2 here, and then we need, similarly we need QR. So if I apply the same thing with the second triangle, what will happen is Pythagoras theorem PQ square equals to PR square plus QR square. I need QR, so I'm going to put QR on one side and rest of them I'll put it on the other side, which is PQ square. If I transpose, that will be minus PR square. So QR will be equals to square root of PQ square minus PR square. Understand this, why we are writing it this way, because to prove angle B equals to angle Q, at least because I've written the ratios thinking in terms of similarity, I need a criteria. That criteria here I'm trying to use as SSS. The third side, to get third side BC and QR, what I got is by using Pythagoras theorem, and I got this second and third equation. By looking at second and third, what I can do is I can divide second by third. So LHS, what will happen is BC by QR. That's what I'm going to get. BC by QR is equals to square root of AB square minus AC square divided by square root of PQ square minus PR square. I'll keep this as third. So now we have nowhere to go with anything else. What we can do is, how do I substitute if I really need that these two ratios are equal to that ratio? I don't have anything to go common with, but I can see that PQ can be written in terms of here maybe AB, or otherwise PR can be written. But then what happens is I'll also bring down something else. So what we'll do is we'll equate this to X. So these two ratios are equal to X. If that is equals to X, so that means I can equate that individually. So AB, any one of them, either numerator or denominator, don't go for both of them. That will, what will happen is you will reverse numerator and denominator. You won't get anything cancelled. We want to get something cancelled so that these three ratios are equal. So if I equate that to X, what's going to happen? Now let's see AB. AB, the ratio involved is this. So AB by PQ is equals to X. AB will be equals to X PQ. Similarly, AC will be equals to X PR by using that and that cross multiplication divided by 1. So AC equals to PR into X. These are the two things we got. We'll try to put them here in the numerator. So BC by QR will become X PQ whole square minus X PR whole square, and that square root is still there, and then denominator square root is still there. PQ square minus PR square. Let's just move this down a little further, scroll it up. So now here BC by QR equals to, I have to square both of them. X square is X square, PQ square is PQ square, minus X square is X square, PR square is PR square. Square root is there, then I'll still have PQ square minus PR square, square root. If I take common X square, will, I will write it this way, so you will know. Okay, let's write X square in the bracket PQ square minus PR square divided by square root of PQ square minus PR square, and we should not forget square root here. So X square root will come as X, so I'm going to write it here. So BC by QR is equals to, X will come out. In the numerator, I will have PQ square minus PR square divided by, again, square root of PQ square minus PR square. So you had two options. Either you change the denominator here with AB and AC by using first equation, or otherwise change the numerator by using first equation. What we did is we replaced only numerator. If not, what would have happened is AB square minus AC square will come in the denominator, and this will go to the numerator, and none of them will get cancelled. So now these two, they get cancelled. So BC by QR is equals to X. If I treat this as 4 by comparing first and 4. What is the first one? Let's go back. First one is our, that part, that one, which is equals to X. These two, that equals to BC by QR, which is here. So that shows that AC by PR AC by PR equals to AB by PQ. That one is equals to X, and this is also equals to X, so that means BC by QR. Now what we did is we proved that ratios of all three sides are same. I can safely say that triangle ABC is similar to triangle PQR. So then I can mention that by CPST or CPCT was corresponding parts of congruent triangles, corresponding parts of similar triangles. Then by CPST I can say that angle B equals to angle Q. That's what they have asked. Yeah, angle P equals to angle Q. So main thing is what you need to remember in this case is try to understand why it's done that way. You can't straight away write equals equals. So the criteria and how we got the third ratio, and then how we proved based on similarity, how we proved those angles are equal. So if you have understood, then you don't need to memorize anything. If you are here for the first time, please subscribe to my channel and then hit that like button, share this with your friends as well, and I will see you next time with some other question. Thank you.